All right, today we're going to take a look at factoring the distributive property. Now, just like we've done with all the factoring, we're going to start off with multiplying something out. And remember how multiplying this goes, and then we're going to go backwards back to the factoring. And so to begin with, whenever we multiply this, we would distribute by doing 3 mountaintops, and the coefficients multiply to make 15. And then x times x to the third makes x to the fourth, so we add the exponents. Then going to the second mountaintop, we have plus 6, because 3 times 2 is 6. And then x times x squared would give me x to the third. So once again, I'm adding the exponents. And then last is 3x times negative 7 would give me a negative 21. And there's no other x's there, so I just bring that x down. And so to begin with, we're just remembering how to do the distributive property when we multiply. Now, factoring the distributive property is going opposite. Okay, we're going to have this problem and we're going to factor backwards. Now, one of the things that we're going to do to begin with is just working on finding that common factor. And so we're going to take a look at this and say, what do each of these have in common? So there are 3 terms here. 1, 2, 3. And all 3 of these have something in common. And whatever they have in common is going to be my common factor. And so first off, looking at the coefficients, 15, 6, and negative 21, all of these look like they're divisible by 3. And so 15 divided by 3, 6 is divided by 3, and negative 21 is divided by 3. So my common number is 3. So now I look at the x's, and I notice that each of these all have x's, but how many x's do they have in common? Well, the first one has 4 x's, the next one has 3, and the last one has 1. So they only have 1 x in common. So my common factor is 3x. Okay, now once you know the common factor, then you can actually look at factoring everything all together. And so when we take a look at this problem, when we know that our common factor is 3x, then after you get that common factor, you'll put that common factor on the outside of parentheses. Then you're going to go back and you're going to take each term, and we're going to factor out the 3 and 1 of the x's. Well, when we factor out the 3, that's the same as dividing. So 15 divided by 3 is 5. And then I have 4 x's, but I'm going to take one of them out. And so that leaves me with 3 x's. And then we go to the next term. 6 divided by 3 is a positive 2. And then if I take out one of those x's, I'm left with 2 x's now. So x squared. And then last, negative 21 divided by 3 is negative 7. And if I take that x out, well, there's no more x's left. And this is how you factor using the distributive property. Is we're going to find the common factor. That goes on the outside of the parentheses. And then we have to go take that common factor out of every one of those terms, and that goes inside of the parentheses, and then you've got your answer. So, and then whatever's left inside, you do want to take a look and make sure that there's nothing else you can factor, and there's nothing else that we can do with that problem. So we're going to take a look at another problem. And so this one right here, we're going to take a look at this and try to see what all it has in common. And so to begin with, I noticed that each of these is definitely divisible by 2. 8's divisible by 2, 6, and 12. But as I look through this, is anything else divisible by something bigger like 4? Well, 8 and 12 are divisible by 4, but 6 is not. So it looks like 2 is all I can take out of this. So 2 is one of my common factors. Then we take a look at how many x's they have in common. Well, it looks like they just have 1 x in common. Okay, just that one right there. The others have 2 and 3 x's, but this one only has 1 x. So I only have 1 x in common in all my terms. So now I put parentheses, and we're going to take this 2x out of each of these. So that leaves me with 4x squared. And then, so I took the 2 out of the 8 to get 4, and I took an x away to get x squared. So now we're going to go to the second term. 6 divided by 2 is 3. And then when I take an x away from x squared, that leaves me just 1x. And then negative 12 divided by 2 is negative 6. And when I take that x away, then there's no more x's there. And so that's factored. Now, we're going to take a look at this and see if this right here, is that factorable? And so, because remember, this is a trinomial. And so we're going to see if this is factorable, and it may or may not be. So we're just going to test it real quick. Now there's a number in front of x squared, so we're going to do slide and divide. And so we're going to take x squared, and we're going to slide that 4 over, plus 3x minus 24. And so we want our factors of 24. And so negative 1 and 24. 1 and negative 24, negative 2 and 12, 2 and negative 12, 3 and negative 8, negative 3 and 8, and 4 and negative 6, and negative 4 and 6. And so these are all the factors of 24, and when I look, do any of these give me a positive 3 answer? It does not, and so my final answer is 2x parentheses 4x squared plus 3x minus 6. And that is my answer because we were not able to factor the trinomial. Okay, so all we had to do was factor the distributive property. Okay, so taking a look at the next one. Once again, we're taking a look at factoring the distributive property. So I want to look to see if they have anything in common. Well, they're all divisible by 2, so I'm going to go up to 4. All these divisible by 4? Yes. 16 is not divisible by 6. So it looks like 4. So 4 is my common number because 12, 16, and negative 20 are all divisible by 4. Then I look to see how many x's they have in common. Well, I've got 5 x's here, 4 x's there, and 3 there. So it looks like x to the third is how many they all have in common, because they all have at least 3 x's. Then, how many y's? Well, 3, 5, and 2, they all have at least 2 y's. And so this is my common factor. So now I'll put parentheses, and I'm going to factor this out. So in my first term, 12 divided by 4 is 3. And then we have 5 x's, and I'm going to take out 3 of them. That leaves me with 2 x's left. And then I have 3 y's. I'm going to take out 2 of them. That leaves me with just 1 y left. So 3x squared y is my first term. My second term, 16 divided by 4 is a positive 4. Then I'm going to take 3 x's away from x to the fourth, and that leaves me with 1x. I'm going to take 2 y's away. That leaves me with 3 y's. Then we're going to go to our next term. We've got negative 20 divided by 4. That's negative 5. And if I take all 3 x's away, then all the x's are gone. If I take 2 y's away, then all the y's are gone. And that's it. This is my answer. This trinomial that's inside the parentheses is nothing that we're used to factoring, so we're good to go at that point. So let's take a look at the next one. Okay, this one only has 2 terms, so whatever I'm factoring out only has to be the same in 2 of these. So negative 9 and 12 are both factorable by 3, but because this first one is a negative, we usually will factor out a negative version. So if 3 goes into these, I'm going to factor out a negative 3. So we usually want that first one to be a positive. And then how many a's do they have in common? Well, 4 a's here and 6 a's there. So they have 4 A's in common. And then how many B's do they have in common? 2 here and 3 there. So they have 2 B's in common. And so then we take a look to see what we have left when we factor this out. So negative 9 divided by negative 3 is 3. If I take all 4 of the A's out, then I don't have any A's left. If I take all the B's, both of the B's out, there's no B's left. So that's it for my first term. So now we'll take a look at the second term. Well, negative 12 divided by negative 3 is a positive 4. And if I take 4 of the A's away from 6 of the A's, I'm left with 2 A's. And then 2 of the B's away from 3 of the B's, I'm left with just 1 B. And that's it. That is my answer. So your first job is to find your common factors. What do they have in common? And then you simply take it out and leave what's left in the parentheses. And you could always notice that if we went back and we did mountaintops with my answer, and I actually did the distributive property, I'd get negative 9 a to the 4th b squared when I did the first mountaintop. And then negative 3 times negative 4 would give me a negative 12 a to the 6th b to the 3rd. And so you can always go back and do distributive property and check to see if you did it right. So anytime you're not sure if you did it right, just go back, do the distributive property, and if you get the same thing, then you probably did it right. Okay, this is our last one. And so once again, we're looking to factor out. And most of us would probably look at this and say, oh, well, we need to do slide and divide. Well, we always want to look to see if we have something in common first. Well, I noticed that all of these are divisible by 7. And so I'm going to factor out a 7. However, the 14 does not have an x. So not all of these have x's. So my only common factor is 7. So when I factor out a 7, I'm left with x squared. 21 divided by 7 is 3. And then 14 divided by 7 is 2. Well, once again, I have a trinomial here, so I'm going to look to factor this. Okay, well, in order to factor this, I only need my factors of 2, which add up to 3. Well, 2 and 1 add up to 3. So this right here will factor into x plus 2, x plus 1. And we have to factor completely. So even if you may factor out the distributive property, but then once you're done, if you can factor the trinomial, then you have to factor that as well. And so this problem is completely factored.